Hello and welcome to the first episode of Duct Tape Development. My name is Sebastian Alman and I'm working on a video game through a small company I founded in 2018 called Madrigal. Now, I've worked in the video game industry as a programmer for 10 years or so, but last year I decided it was time to do something a little different to see what I can come up with as an indie game developer. So I founded my own company and started working on my own game. And for a time now, I've thought about starting some kind of devlog to document the work I'm doing and make people aware of the project. And making videos seemed like a nice way to do that. But I have not done any serious streaming or online development or anything like that before, so I wasn't really sure how or where to begin. And if it looks like I don't really know what I'm doing video production wise, then please let me know in the comments below. Basically, I just decided to start recording some of the tasks I'm working on and call the video series Duct Tape Development, because these videos will just be sort of thrown together with a very minimum amount of planning and editing. The point of this series is really just to give you a window into my day-to-day life as I'm working on the game. Now, these videos probably won't be very regular. Instead, whenever I feel I'm working on something that's interesting to watch, I'll upload a video. And I also think it makes for better videos if I have a rough idea of how to do the task. So I'll select something that I kind of know how to go about. That way you guys won't have to watch me scratch my head for an hour trying to figure out what to do next. Cool. Okay, let's get started. So as this is the first video, I'll introduce the project a little bit and then we'll do some light development. So let's look at the game first. Now this is paused, so that's why there's no movement or sound. Please keep in mind that I'm a programmer and not an artist, so anything that you'll see at this point is going to be placeholder graphics. But then again, this is very early in development still, so I don't really mind how it looks. But keep in mind that, yeah, pretty much everything will be replaced by nicer assets later down the line. Cool. So the game is called Slide currently, and that's really just a project name that I had to come up with when I needed to name my folders and source code repositories and whatnot. I have a pretty good idea of what the game is going to be called already, the actual game that is, so Slide might not be a very long-lived project name, but currently it's called Slide, so if you see it on the screen, just note that that's the project name. Okay, so what's the game about? Well, you can see that it's kind of a car game, and let's unpause it and we'll see some action going on. So here you have an AI guy driving around the place. This is just a test level that I've put together to help me with developing some of the features that I'm working on. The game design is kind of like a mix of the vehicular parts of Halo, with the combat and the exploration and all that. Maybe a little bit of spin tires with the physics puzzles, and even maybe crossed with Interstate 76 from back in the day. So if you can imagine those three, then you have a pretty good idea of where I'm going with this. Yeah, we can drive around the place a little bit. I'm driving with the keyboard now, which makes it a little tough, but I'll see if I can manage. The stuff I'm working on currently is the combat, and that's very, very heavily in development at the moment. So basically, you can shoot stuff, but there are very little effects, and there's really just a debug line where the bullet would go, which is the green line that you'll see. But you can already affect objects by shooting at them. These are physical objects, and you can even cause damage to cars like this, and they will unceremoniously die and be removed from the world. You can actually even shoot yourself. So let's not do that, because then we'll have no car to drive around with. And that brings us to the topic of today, which is explosive barrels. And these are your typical video game explosive barrels. Usually you shoot them a little bit. At some point they probably start burning, they catch fire, and if you shoot them a little more or you wait a while, they will explode. And that part actually works fairly nicely already. So if you shoot this a little bit, you'll see that the health is reported, and the full health for one of these barrels is currently 100. And if you shoot them enough so that they reach 50, they sort of catch fire, like this. And now you can see that the barrel is actually losing health all by itself because it is on fire. And when a barrel reaches 0 health, it will explode. And that will send other objects flying and give damage to them as well. So you can cause all sorts of interesting chain reactions. So that part is cool, but it's a little bit unintuitive currently because you can't actually see that the barrel is on fire. You just see this weird debug text, which is not very nice. So I figured that's probably the first thing that we're gonna add today in this episode of duct tape development. Also, I'd like to add a hit effect. So a bullet hit effect. When you shoot the barrels, there would be a little bit of a spark coming off them. Now you can actually already hear that there is a hit sound effect. So if you shoot the ground, you can't hear anything except the sound of the gun itself. But if you shoot one of these barrels, there's kind of a metallic sound, like a bang. The nicely randomized pitch. And so I figured if we add a particle system, like a visual spark, combined with that sound effect, it should be quite nice. And then we'll probably just remove this debug text. So cool. Let's do just that. But before we do that, I should probably introduce the game engine a little bit. So I'm not using any kind of off-the-shelf engine for this project. Instead, I'm using a game engine that I've been developing myself for a number of years already, called Basis. So this is the logo of the engine. You can see here that we're using the Slide project currently. And if you open up the editor, it looks something like this. We can open up the level we just looked at in the editor, and it will we will look roughly how you would imagine. You can move things around. You can see the properties here. You can add more objects. You can modify the terrain. The typical things you can do in an editor like this. Obviously, this is not as advanced as something like Unity or Unreal, but it doesn't need to be, at least not for this game. And to sort of start today's tasks, I figured we should probably have a look at what goes into one of these exploding barrels. So looking at the object inspector, you have the object name, in this case explosive barrel 11. Under that we have something called the object type. And the way you compose objects in Basis is a little different to something like Unity. You have a list of components, and these are kind of, at a first glance, they might look a little similar to the component list in Unity, but you don't actually add any components to this list in the editor like you would in Unity. Instead, you build up something called a game object type, and the game object type has something called a blueprint, not to be confused with Unreal blueprints. The blueprint of a game object type in Basis is really just a list of the components that make up that type. And so the explosive barrel game object type blueprint has these components listed, minus this editor component, which is actually added automatically by the editor when you open up the editor. And this just allows you to like hide the object and lock it so you can't select it, etc. But then you have the transform, which tells the system where the object is and how it's rotated and whatnot. You have the mesh, which is really just this 3D model barrel object. And then you have 3 components that will be kind of interesting to the task that we'll be looking at today. So you have the explosive object component. You can see the component type here. That's the component that makes the object catch fire when it receives enough damage. It's also the the component that makes the barrel explode after it's reached 0 health. Then you have the material effects component, and this is the component that determines what kind of sound effects and visual effects and whatnot that happens when this object is interacted with. So this is a component that you can add to any object, sort of. For example, if you have a rock and you shoot it, it might produce a different sound than if you shoot a barrel, for example, and this material effects component would determine those sounds and visual effects. And then you have something called a game unit, and a game unit in the vocabulary of this game is really anything that has a health that can be harmed in one way or another. And obviously, because these barrels have a health, they also need a game unit component. They also have a faction, and this might seem a little weird because why would an inanimate object have a faction? But there's actually a faction for inanimate objects here. That allows us to do some pretty interesting things, like have the AI units in the game look for inanimate objects and target them, and they might, for example, target an explosive object right next to you and damage you that way. But yes, so this game unit object or component is something that you might add to a vehicle, for example. And in that case, the faction would be something else than inanimate object. Another thing that is worth pointing out at this point is that the game engine uses a client-server model. And so what does that mean? Well, if you look at these components, then they all have this created on section. So the transform component, for example, is created in the editor. It's created on the client and it's created on the server. The mesh component is created only in the editor and on the client, but not on the server. And then we have two components that are created on the server and one that's created on client and server, but not in the editor. So first of all, whether or not it's created in the editor, well, that does pretty much what you expect it to. So for example, now that we're looking at this object here in the editor, it doesn't have an explosive object component. It just doesn't create that when we're looking at it here, because we really don't want our explosive barrels to blow up in the editor. We could have that functionality built in, though, if we wanted to. We could, for example, have it sort of simulate the physics in the editor if we wanted to, but we don't do that here. As for the client and the server, well, the game engine is built from the ground up to support multiplayer, and that means that one of the easiest ways to achieve that is to have kind of a client and a server split built into the whole game object model. And that means that when you start up a game, it starts up a server, and then you can have a number of clients up to 32 connected to that server. And the game logic, or at least the most critical parts of the game logic, will run on the server. Things such as dealing damage to objects are things that you want to run on the server rather than on a client, because the clients can be cheaters, essentially. And you want the actual server to tell an object when it's receiving damage and when weapons hit or when someone scores a kill. And so this explosive object component is running on the server currently. The mesh, on the other hand, which is a visual thing, that is stuff that you want to do on the client. And it's also in the editor here because you want to see it in the editor. But the server doesn't have access to the renderer. The server only runs the logic part. And then it tells all the clients at regular intervals, sort of propagates all the data to the clients, and the clients can then render the world. The clients also capture input, that is the input that's read from your mouse and keyboard or gamepad, and sends that back to the server. So that is sort of how it works. And we need to keep this in mind. For example, if we want to add the fire particle system to this explosive barrel, we probably want to add it to this explosive object component. However, this component is only created on the server currently, which means that if we were to draw the particle system from that, it wouldn't work because the particle system is a renderer concept and the server doesn't have access to that. So we're going to have to do something about that problem. All right then. I'm just going to drag this back here. At this point, I think I should probably demonstrate a few particle systems. Now, I've prepared a couple of particle systems for this because, like I said, I'm no artist, so this stuff doesn't come all that naturally to me, and it takes a while for me to actually get particle systems done. And so I figured I'll just do them up front so that you don't have to watch me fiddle with visual values all the time. It's actually just, you can copy this, the position of this guy, and add a new particle system here just to demonstrate what they will look like. So for the fire, I made something called the barrel fire, and we can demonstrate what that will look like in the editor. So something like this. I mean, it's not the nicest thing ever, but I think it will look quite all right. And this is a particle system that should be placed sort of in the middle of the barrel. However, we don't want to actually rotate the particle system along with the barrel. That won't look nice. So for example, if we have this and we try to rotate it 180 degrees so that it's facing downwards, you have this weird downwards facing fire, and that doesn't look right. So regardless of how this barrel is rotated, we don't want to actually rotate the particle system. On the other hand, the bullet hit particle system is a particle system that we want to rotate. So let's have a look at that next. So we have bullet hit metal, and this is just a small spark, but this will be played for each bullet that hits the barrel. So I think it will look pretty nice when we have it for each and every bullet in our rapid fire turret. And this is one that we definitely want to rotate. So obviously it's just going to sort of be played and then it's gone essentially. But if we rotate these, then the particle system should definitely be rotated so that it's facing kind of outwards from the surface that it's hitting. Like again, if we rotate this 180 degrees, and it just kind of goes into the barrel, and that doesn't look correct. So we'll have to take that into account when we're applying these particle systems. Okay, I think that's probably, actually I don't need to do that. I can just shut down the editor for now. Before we do that though, I'm gonna copy the path to these particle systems. So we have the particle system for the bullet hit metal, and these are just text strings. And then we have the barrel fire one, and this is just one way to copy the paths. All right. As for the actual programming, the game is written in C++, and so is the engine. Now, to be able to follow along with these videos, you need a little bit of understanding of how C++ works, but I won't go into any crazy details. If you understand enough to follow along with, let's say, an Unreal Engine 4 programming tutorial video, then you probably have enough to follow along with this one as well. regarding the videos, this is not gonna be any kind of game development tutorial video series. I'm not claiming I do things in an optimal way. This is just kind of how I'm working on this particular game. So don't take this as any sort of the way you're supposed to do things. This is just how I'm doing things, at least currently, and my opinion might change later on as well. That said, I'm very happy to discuss any implementation details or solutions to problems, and if you have any questions about any of the systems that I have working here, then by all means ask those questions and I'll try to answer them as best I can. Or if you want me to go into further details on some of these things, then let me know as well. Okay, so here we have one of the components in C++. This is the game unit component. And the component in Basis is really just a C++ class that derives from Basis game object component. There's a little bit of macro magic going on though, and you are probably, especially if you worked with Unreal, you probably know that they use a bunch of macros to sort of hook into their engine interfaces. They do it with a preprocessor step though, and the macros are really just kind of placeholders for their own tool to figure out where to generate the code and how that code is going to look like. Now, I'm using macros as well, but these are actual C++ macros, so there's no pre-processing step going on here. And for this component, for example, you use this kind of macro to specify that okay, this is a game object component. It has something called an exposed property map, and if you remember in the editor, you were actually able to set this faction in the inspector window there, and that's why it's added to like a map like this. If we look at something like the nav mesh builder component, this is a map that has a lot of different members, and these will all show up in the editor. It also has something called the blueprint properties object, and for that to make sense, we probably have to look at the blueprints next. So let's go back into the text editor, and this is one of the areas where it really shows that this engine is really just a one-man project, because this is how you edit the blueprints currently. There's no nice editor or anything like that. I have it planned, but I haven't gotten around to doing that yet. But if you look at the explosive barrel blueprint, this is really just the same list of components that we saw in the editor, minus the editor component that's added by the editor itself. But you have the explosive barrel game object type. It has a list of components. It has the transform, and the transform is a dynamic body transform component. You can give it some properties here. It's a cylinder, it has a height, a radius, and a mass. This is just like your typical physics object properties. It has a mesh. We actually set the mesh to use here, and the material to use, etc. And these are called blueprint properties. So the dynamic body transform component has these blueprint properties, the mesh has these blueprint properties, etc. And if we look at the game unit component, it also has some blueprint properties, namely the faction and the full health. The full health, as we already mentioned, is 100, which means that if you wanted to, with the current setup, if you wanted to create an explosive barrel that is super durable and it has 500 health, then the way you would do that is you would create a new blueprint and add a game unit component to that one as well, and set it there. And blueprints can also derive from other blueprints, so you can, in theory, just override that value. But yes, so we have the game unit component here, and this is where we create, or where we set where the component is going to be created. So it's created on the client and on the server. And it has these two properties, and the properties are brought into the code using this class. So if you go and look at what that class looks like, it looks like this. It derives from basis blueprint properties. It has a faction and a full health. These bools are just helpers for me currently, because these properties can be set both through the editor and through the blueprints. But yes, so faction is set to inanimate if you don't set it through the editor, and full health is 100. Cool. Let's look at another component. This time let's look at explosive object component. Now this one also has a blueprint properties object, and this is one where we actually I think we should add the fire particle system path to this one. So if we look at what we have the explosive object here and the material FX here. Well, we can see that the material FX component actually already has a bullet hit particle system path property. It's just set to empty, and the code actually doesn't use this yet, so we're gonna have to do something about that. But we can already copy in the bullet hit path. So let's just paste it there. But the explosive object, this actually doesn't have any perimeter for the fire particle system. So let's just add that. So let's call it fire particle system path, and we can just copy this one in. Cool, so now it exists in the blueprint, but the game doesn't really know what to do with this name yet, so we need to somehow bring it into the code. So since this is the explosive object component and these are the properties, it's going to use this explosive object component blueprint properties class to bring it into the game. So we'll add one more string here called fire particle system path, and then we need to actually implement these serialization and deserialization functions for the type. So we have binary serialization and deserialization, and then we have the thing that actually loads them from the JSON file. I'm just going to copy this previous line because it's also reading a string. So we get this data in. We need to specify where we put the data, and in this case it's the fire particle system path, and that also happens to be the name of the data here. So if the string fails, it will return false, and otherwise it will load it and put it into this member here. Okay, cool. I think that's probably all the data work done. At this point we can just build the game and make sure we haven't done any stupid mistakes. And in the meantime, that actually built pretty fast. We can start looking at the fire particle system next. Oh, actually, there's one thing we need to do still. As I mentioned previously, this explosive object component needs to be created on the client if we want this component to actually draw the particle system. So we'll just add the client true here as well. By default, components are not created anywhere, so you need to actually specify. Yeah, they go there, they go everywhere. This is not actually the format that the game is reading these into. They get sort of exported into a binary format on the fly as I'm editing this file. I have something here called the basis assets server. It looks a little something like this, that processes this data on the fly in the background. So if I make a mistake like this, for example, the system notifies me that actually I didn't fail to convert, and you can go have a look at what the problem is. And now it should have converted fine, and it was actually already up to date in the cache because I just undid the change, so it doesn't matter. Cool. All right, so now we have this explosive object component already or on both the server and the client. Now we need to do something with that fact. So if we look at this component, it has a bunch of methods, and most of these are actually overridden from the base component. So we have create, destroy. These are obviously the methods that get called when the component is created and destroyed, and we have onParent created, which is called when all the components of the parent object are created. And then we have something called tick, and tick is the fixed rate game update method, which means that this is where you would want to put most of your game update logic. There's also update, which is called every frame. So if your computer is very, very fast and it renders the game at 500 frames per second, then update will be called 500 times per second, but tick will still only be called at 60 or whatever your fixed tick rate is set to. But for slide it's currently 60, so tick will get called 60 times per frame for this component on the client and 60 times on the server. And so if you look at what this actually does, well, in here we get the health from the game unit component, and we see if it has reached the fire health threshold. If it has, then we calculate the time since the last fire damage, and then if it's time to apply some more fire damage, then we do that. And finally, if we reach 0 health and we haven't exploded yet, then we explode. And exploding just it applies the radial impulse and it deals a bit of damage, and yeah, we don't have to look at that because it basically works how it is supposed to work. But yeah, now that this is running on both client and server, we probably want to specify here that only run this fire apply damage and explode on the server. So we can do it like this, just checking if we're on the server or not. And we could in theory do this on the client as well, but it doesn't really make any sense to do it there. And the more we can do on the server, the better, because server runs on a dedicated thread, and it doesn't perhaps affect your client frame rate as much as running stuff on the client, which should be busy rendering your game and not caring about whether or not the health has reached a certain level. That's the server kind of stuff. Right, so let's add an else here for the client stuff. So that's where the client stuff goes. And I already have some ideas of what I want to put here. I think I'm going to want to update the particle system position on the client side if we have a particle system running. Normally you can just attach a particle system to a game object and it will sort of follow along with it naturally. However, as we previously discussed, we don't actually want to do that with the fire particle system. It should move along with the barrel, but it shouldn't be nested underneath it, because we don't want the orientation or the rotation of the barrel to affect the fire. It should always just be sort of going upwards. So I don't think I'm gonna nest it underneath the barrel. I'm just gonna update it manually. All right. So in here, actually not there, but in here, if we reach this place, then we are effectively on fire, and we should notify the client about that somehow. And the way we can do that is with something called a propagated value, and we can make it a boolean. Oh, actually I need to specify the namespace, and let's call this on fire. So this is essentially a normal boolean, but it is a boolean that is sent over the network and sort of kept in sync across the network between the server and the clients. Normally the party that writes to this to these propagated values are the owners of the component, and by default the server owns every component, which means that the server is the only one who is allowed to write and propagate values across the network. The server can also give ownership of a certain component to a client, which means that the client is then the one who gets to write to these, and the stuff gets propagated to both the server and all the other clients. But yeah, we don't use it in. I don't think there's a single piece of relinquished server ownership in Slide, so let's not care about that. But yeah, that's a Boolean value that we can check if we are on fire or not, and we probably also want a handler for that. So let's call it something like on caught fire, and I think if I remember correctly, it needs to look like this. So we have the value here. I can't actually remember that. Let's have a look at the dynamic body transform component, which has at least a handler. Yeah, so if you want to add a handler to a propagated value, it needs to look like this. And this is a function that we can hook to this propagated value, so that when this Boolean changes, this method is called, and it will get called with the value, and you can see if it's a local change or if it was changed across the network, and also the time, which is quite often not needed. And we can just create an implementation. I don't really need the namespace there. We also need to initialize the propagated value, and it's done like this. So we specify the component that it belongs to, and the name for various debugging reasons. Then we specify if this is if this is a reliable propagation or not, and if you have a lot of these things, and overall in multiplayer development, you don't want to necessarily make everything reliable, because that will just flood the network connection unnecessarily. However, in this case, I think this can be made a reliable propagation, because this is not updated every frame; it's just updated once for each barrel. So it can be reliable, but it doesn't necessarily have to be immediate. Stuff that's not immediately propagated are kind of propagated according to a priority system. So it tries to kind of balance out the network traffic a little bit. And then the initial value, which is in this case a Boolean as well, and it's false. We're not on fire at the start of the game. And then we can hook up the handler for this, or value changed callback as it's called. So let's make a delegate, and it will be called on this object, and the method that it will be called is explosive object component on caught fire, like this. And this will be called on both client and server. So as the first thing, let's actually add an on client here, because we don't really need to do anything with this on the server. I mean, we could only hook up this handler on the client if we wanted to, but that's not usually how I do it. I just check the on client value here, and then maybe I can do something on the server here later if I wanted to. And then finally we need to actually write that. So I'm gonna do a check here that if we're not on fire, then just make us on fire. So set the value to true. You don't actually assign values to these, rather you use get and set, and there are a few different versions of these depending on how you want to do it. In theory, you could just call this set true without this if, but that would actually propagate the value over the network every frame then after it's reached this, because again we're in the tick here, so this is going to get called multiple times and we don't want that. So I'm checking the value once and setting it once. Cool. Now we should have everything we need as far as the network propagation is concerned, and we should also have the fire particle system path here ready for us to use. So how do we play the particle system? Well, let's go to the header, and I need to forward declare the basis particle system class here, and we'll need to make a member of that type. So let's use basis particle system path. Oh, sorry, particle system, and then just call it fire particle system, like this. And we should initialize this to null pointer. And in here, we can actually assign and instantiate the particle system. But before we do that, we should include the necessary headers. So the particle system is in the particles folder, and we need the particle engine, which is the engine level kind of system for playing back particle systems. And then a particle system itself, we need that as well. And the particle system, for those who aren't aware, this is just sort of an effect, if you will. So the bullet hit spark effect will be one particle system, and we can instantiate multiple instances of that. And the fire is also a particle system, and it's a kind of a more long-lived particle system. It sort of keeps on burning until the barrel explodes. So let's create the particle system here, and we'll do it by using the particle engine. We get the instance of that. It's a singleton, and we can call instantiate, and here we have the properties fire particle system path. And here is, as I mentioned previously, you can either attach it to a scene node, and we actually have a scene node, but let's not use that. Let's just use a world transform. So essentially just telling the system where it is and how it is rotated. And like I already mentioned, we don't actually want to rotate it at all. So we can just create a matrix, 4x3 matrix, and use quaternion identity, which is essentially no rotation. Just keep it kind of facing upwards. The position is the current position of the barrel, and we can get that from the transform component. Get position. Oh, not parent. Like that. So that creates the matrix that it wants, and then we instantiate it not as paused, so it starts playing immediately. And if we were to run this now, then the particle system would play properly, but it would actually not follow along with the barrel. So let's fix that. We have this particle system, and here inside the client stuff, if we have a particle system, then we need to set the world matrix, and we just do the same thing as we did here, but we need to update it every tick so that it follows along with the barrel. So let's make it the same as we had there. So this just set the world matrix again. You can do that as often as you want, and the particle system will move to that position. Cool. And the last thing we need to do in this component is get rid of the particle system when the barrel explodes. Now we don't actually run this explosion code on the client at all, but I happen to know that when the barrel is exploded, it gets removed from the level, and we can use that information to our advantage and simply just add an if here. If we have a particle system, what's called fire particle system, then we use the particle engine and release the particle system. And we don't need to kill it immediately, but we will want to stop emitting. So it will essentially just sort of, it will leave the particles that are already emitted, and in the air the smoke and the fire will get to sort of naturally dissolve and sort of get removed. There we go, and then we can just null this back. Cool. Okay, let's build this. Let's see if we made any mistakes, and then we can actually try it out and see what it looks like. Okay, so we need to cause enough damage to one of these guys. When they reach 50, they catch on fire. How cool is that? And the answer is it's pretty cool. I think the fire damage actually is a little low. I mean, these guys actually stay burning for quite a while before they explode. I think we need to do something about that. But yeah, that's a pretty good start actually. Yeah, that kind of works. At least as a placeholder, it's pretty nice. Huh, the AI just drove into the trailer. Yeah, the AI needs a lot of love still. Okay, cool. I'm gonna change the fire damage rate to, I think, 12, so that it's three times the amount it used to be, which means that the time it stays burning will be significantly less. And also I think I will lower the explosion max force a little bit, because now oh, actually that's not the one I wanted. Yeah, that's actually not the one I wanted. I wanted actually the turret. Yeah, let's have a look at where's the turret of the car. Yeah, so here we have, there's quite a lot of commented out code here, but we have the car. The car 1 is the one that we're using. It derives from another blueprint called car 1 base, which just means that it essentially gets all the components from car 1 base, and then you can add your own stuff on top of that. And that has a hit scan turret component. I think the hit force needs to be a little lower, so let's make that I don't know, 40 or something like that. Because now the barrels just kind of bounce around like crazy when you shoot them, and it's not perhaps the point. All right. Let's do one more thing. Let's go to game unit component. And here you can actually see, so here we're not using the tick, here we're instead using the update. And in the update method you can do things like things that you want to be updated every frame. So every time the game is rendered, for example. And this is where we draw the health string. Let's just get rid of that, and it should be a little nicer to look at when we don't have that annoying red text there. Alright, it's already a lot more exciting, because you don't know which one of these are gonna explode and which ones aren't. Which ones are close to catching fire and which ones aren't. But yeah, I think this works pretty well. It's also really fun to just launch these guys into the purple boxes and see them fly. Never gets old. Okay, so that works really well. now we only have the hit effect left, and I think we have pretty nice looking explosive barrels. Now, if you remember, I mentioned that the material FX component is the component that plays the hit effects, and it actually has a play bullet hit effects method, which gives us actually everything we need, because we need the position and we need the surface normal. We don't actually need the hit direction to be able to play this effect, but we need the position and the normal. And this is called, let's see where this is called from, if we look for references to it. It's called from Weapon Utilities, and this is where we apply the hit scan damage, and then if it has a material FX component called play bullet hit effects. But this is called on the server, and so again we can't play any particle systems on the server. We need to somehow notify the client that it needs to play a particle system. And for that purpose, I've implemented something called the FX events. And these are not reliable network events, so unreliable network events. And you're only really supposed to play kind of one-off effects here. So they're really good for things like sound effects and particle systems, because if you have a lot of stuff going on the screen, and especially if you have a lot of stuff going on the network, then you don't want to flood the network connection and bog down the experience just by playing lots of particles effects and screams and explosions and whatnot, and have that sort of add congestion to the network connection. You just want to send them with like a best effort sort of mechanic, but not really care if they get lost on the way, because some of those explosions might be behind the player, and not or some of those sound effects might be very far from the player, so it doesn't really matter if they get lost. And yeah, this FX event system is for stuff like explosions and sound effects and other kind of one-off, play and forget kind of things. And so these bullet hit effects for these explosive barrels are a really good candidate for something like that. So how does this actually work? Well, since we are now on the server, this material FX component is on the server. What this actually does is that it calls FX events send, and it sends an event to the client, which will then play the thing if it receives it, or not play the thing if it gets lost on the way. And since we're now working in a single player environment, still writing multiplayer compatible code, but mostly working in a single player environment, it will never get lost, because this single player network layer doesn't have any packet loss, so don't really have to worry about that. So we have something called the FX event client, and you can see here that it has two methods in addition to this boilerplate stuff here that does interesting things. So we can play a sound and we can play a particle system, and that's already sort of what we need. However, we do send a lot of the same information over, namely this position here is going to be the same for both the metallic bang effect and the particle system. So I think we should really just create a third one which bundles everything together, because we want to save on network bandwidth. And as you can see, these are actually marked as RPC void. And what does that mean? Well, this is really just a type def for normal void, so they don't return anything. But RPC is a system that allows you to call a method on one side of the network and have it execute on another. So these are methods that can be called on the client, they can be called on the server and have sort of the system executes them on the client, which is exactly what we want, because material FX is on the server and the actual playback of the particle system sounds are on the client. And the way we do this is we have this FX event client here. So let's add, first of all, let's add the method that we want to call. So we'll call it RPC void. And as I mentioned, these are just type defs for normal void, so they don't really do anything. They're just kind of signals to the one who's reading the code that, oh, okay, this is actually an RPC, or remote procedure call. And we can call it something like play bullet hit effects, something like this. And we need the position, and we need the surface normal, and that will allow us to rotate the bullet hit particle system so that the sparks kind of fly out from the surface. Then we also need this one. We need the sound event path, and then we need the particle system path. But I don't want to send a string if I don't have to, and I know for a fact that I don't have to do that if I want to play a particle system. I can only send the hash of the string, which is a 32-bit number generated from the string, which is a lot faster and better to send over the network than a full string. So let's call this particle system path hash. Now ideally I would like to send this sound event path as a hash as well, but this is fed directly into fmod, the fmod audio engine, which doesn't know what to do with my string hashes, at least not yet, until I set up a system that allows it to do the kind of reverse lookup. So I'm gonna have to send the string currently. It's not great, but we can live with it for now. Okay, cool. So let's actually implement this before I show you how to do the RPC part, which allows us to call this from the server. But we can essentially, we want to do this. We want to play the particle system at the position, but we want to orient it properly. So let's make another matrix 43 and call this particle system matrix. And the 43 is really just, this is a 4x3 matrix, which allows us to store the position and rotation and scaling of something in 3D space. Right, so what we will want to do now is place it at the position, and it's supposed to look along the surface normal. So the surface normal is the vector that runs perpendicular to the surface, kind of points outwards from the barrel, if you will. So let's have a look to, and we can use the safe version of that. So I direction would be surface normal, and the up direction is just the world up, which is the y-axis in this game engine. And then we also want to set the translation or the position for the matrix to place it in the scene at the correct place. And then we can essentially do this. So what we're doing here is something a little bit similar to, oh, I need to actually make this part of the class. What we're doing here is a little bit similar to what we did with the fire particle system, except we release it immediately. And if we look at the parameters here, we don't kill it immediately, and we also don't stop emitting. And this will make the particle system kind of play naturally to its end, to sort of let it finish. But after it is finished, this will release all the resources and references to the system, so that we don't cause any memory leaks. Right, and then we also want to play the sound, and we can essentially just copy this part over, except it's not called sound position, it's just called position. Cool. And so we want this to run on the client, but we don't have any code that actually can execute this on the client. So what do we do? Well, now that we have the RPC method implemented in this class called the FX event client. Oh, I actually have a mistake somewhere. What did I do? Oh, I need to fully specify the string hash. Right, now that we actually have the code here in the FX event client, and it's marked as RPC void, we can expose it as an actual RPC or remote procedure call. And the way we do that is with a little utility that I've written for this very purpose. So we have something called the FX client IDL, or interface definition language. And you can see that this FX event client here is the same thing as here. And we can copy this whole function without the return type and place it in this IDL file like this. And what this does is essentially you can list all the RPC callable methods in here. So stuff that can be called remotely on an FX event client instance. And you already had the previous ones here, and they're all, as we mentioned previously in this case, they're all unreliable, so reliable false. And once we have this done, we can run a little bat file which runs this RPC IDL compiler. And no errors, no warnings. This will generate the interfaces for us, so it generates the code that essentially takes care of serializing and deserializing all the data that we send, etc. RPCs can also have return values, except they work a little different than normal return values, because you don't typically want to block the calling function waiting for the other side to respond, especially not with a reliable with something set reliable false, because it might actually wait forever if the message is lost on the way. And this RPC compiler kind of takes care of generating all of that code for us. So if we now look at the version control handler, what it actually did was it generated, or rather in this case added to something called the FX event client RPC proxy. It created a new function in here. And if we look at what this actually does, it created a new ID for it, and it generated a method that looks exactly like our handwritten play bullet hit effects method. But rather than playing any sounds or particle systems, it just serializes everything into a network message and then sends that over the network. And that version of the method is the one that we can call on the server. So now that we have this, we can go back to our material FX component. We can actually comment this one out because our new method plays the sound as well. And we can do FX events send, which actually, as you can see, it returns the proxy. We can now call. Oh, yeah, the IntelliSense actually hasn't picked up on our new method that we added. So let's have a look at what that actually looked like. So we have the position, surface normal, sound event path, and particle system path. So that would be hit position, hit surface normal, and then we have properties, bullet hit sound event path, and then also the bullet hit particle system path. We actually want to send only the hash, so we just get the hash out of the string, and that's it. Yeah, for some reason the IntelliSense doesn't seem to like our new function, but that occasionally happens, and yeah, it succeeded nicely. So I'll probably take like a Visual Studio restart for it to pick up on that. Okay, cool. So now that the bullet is hit, this will get called on the server. We'll call this, which will cause our actual function to get called on the client, and we'll play the particle system and we'll play the sound. So let's see how that looks like. Okay, cool. Yeah, the effect is a little bit extreme perhaps, but that can be tweaked. That's something that can be adjusted in the particle system itself. But I think this actually looks pretty alright. You sort of get the feeling that you're really shooting at metal here. Alright. Fun. Yeah. It makes it a lot nicer when you can't see the actual health number anymore, because you don't really know what's gonna happen and in which direction these things are gonna fly. And you get some nice chain reactions as well. Everything's just going off at the same time. That's fun. Okay, I think that's probably enough for this video. If you made it this far, thank you very much for watching this video, and I hope you got something out of it. I think I can already feel myself getting better at this video thing, but we'll see how that turns out. If you have any questions about any of today's material, or if you have any things you'd like me to cover in more detail, just let me know in the comments, and I'll see what I'll do next time. Today was a fairly programming heavy session. I think next time we might do something a little different. For example, do a little more level design or scripting and sort of set up some kind of scenario, because I realize that programming on this level is not perhaps everyone's cup of tea, so I'll try to mix up the content a little bit. But this was nice. We got some work done, and I got to practice my video recording skills. Okay, have a good one, and until next time, bye.